And welcome to the Iowa Learning Farms webinar. It is Wednesday at noon, and it's a pleasure to be here with you. I'm Liz Ripley. I'm the Conservation and Cover Crop Outreach Specialist with the Iowa Learning Farms. And I'm thrilled to have with us today Brian Dougherty. He's an agricultural engineer for Iowa State University Extension and Outreach, and he's going to be sharing with us some of the research that he's been working on in Northeast Iowa, but across the state on improving manure management to maximize agronomic and environmental outcomes, might impact your income. So I'm going to turn things over to Brian to take it from there. And if you have any questions along the way, feel free to submit those in the chat and we'll get to them following his presentation.
Okay, does that look okay on your end?
Looks great, Brian.
All right, so yeah, today I'm just going to be talking about some best management practices that we can use for, maximizing the amount of value you get out of our manure nutrients and minimizing losses. And then I'm going to get into some research that we've done at the Northeast Research and Demonstration Farm. So we've got some water quality results that I'm going to share, got some cover crop data. We did a manure timing study as part of that, and then some nitrification inhibitor work as well. So just starting out with the best management practices, there's kind of three things, kind of main points that I like to go over when I talk about this. And the first one that we want to focus on is just reducing those pathways for nutrient loss. So I've got four main pathways listed here. I'm primarily going to focus on liquid manure today, but some of these can apply to dry manure as well. But denitrification would be the first one. Now, that one's a tough one to manage. The main thing you could do there is just improve your drainage and, minimize the amount of time during which that soil is completely saturated and anaerobic. So volatilization, we can definitely impact that with management, and I'll get into that. Leaching, we can also impact with management. And then surface runoff as well. Those last three, we definitely can minimize those depending on how we manage our systems. And so I find that poop emojis are useful for, explaining these complicated environmental processes, but it's really pretty simple when you boil it down. We want to keep those manure nutrients out of our water, and we want to prevent that nitrogen from volatilizing into the atmosphere. Those are really our two goals when you boil it down. The second point I make is we need to apply that manure at a consistent rate and at the right time. So calibrating and maintaining equipment, I'm not going to talk about that a lot, but super important for getting a consistent application rate across the field and getting the rate that you're trying to shoot for when it comes to a nitrogen application. And then avoiding early fall application. I'm going to show you the Nashua data on that and what we're seeing there, and or plant a cover crop. So you can see the picture on the right there. I kind of cheated a little bit there. That's actually a picture of our 60-inch early interseed plots at Nashua. But in a perfect world, that's what our fields would look like in the fall. We'd have an already established cover crop there to inject manure into to help catch those nutrients by having a living root in the ground there as we're applying that manure. Just a nice visual here, just talking about equipment and the importance of making sure that that's being maintained properly. The ag engineers did some work on this several years ago. And what they found was these little white vents on the top of the manifold here, those can get plugged, and also having loops in your hoses can be an issue there. And you can see the effect that that's having on, the application variability across that toolbar. So just an important reminder there to make sure you're checking out your equipment before you go out and start applying. And the third point I make here is I like to think of manure as an investment. So the minute that feed truck pulls into your driveway, or you spend all the money for inputs to grow a crop to feed to your animals, you've basically already paid for that manure. It's no different than pre-booking your fertilizer. So we want to make sure we get that investment back. So don't over apply nitrogen. You can use the nitrogen rate calculator that's available for a number of Midwestern states. It's a little trickier to use it for manure because you have to make some adjustments for volatilization and other factors depending on how you're managing that manure, but you can use that nitrogen rate calculator. And then you really need to just focus more on improving nitrogen use efficiency. I'm not going to get into the details on how to do that today, But we have a number of producers here in Iowa that are down in the 0.5 to 0.7 pounds of nitrogen per bushel of corn range. And that's a very good nitrogen use efficiency. So it is possible to achieve that. And then the third point here is Dr. Antonio Mallarino has done a lot of work looking at phosphorus applications and soil tests. And what he's found is that basically if you have a phosphorus test on a Malic 3 or a Bray of over 25, you really don't see any economic advantage to putting more phosphorus on beyond that. So look for those fields where you've got a low testing phosphorus, so 25 or less ideally if you have fields like that, and target your manure applications there because you're more likely to get an economic boost from the phosphorus side of that manure application. And you can justify hauling a little bit further to do that. So just looking at nitrogen in a little more detail, we've got our different pathways of loss here. And basically what we're trying to do here is just shrink those. We want to make those arrows smaller and keep as much of that nitrogen as possible either in the soil system or available for crop uptake. The way we do that is by injecting that manure or getting it incorporated immediately. That can significantly help with the volatilization issue. Focus on application timing. Generally, the closer to when that crop needs those nutrients, the better. That can help with our crop uptake. And then using cover crops can help pretty significantly for both the leaching and the runoff and erosion components. Phosphorus is a little simpler. We don't have to worry about volatilization, but basically the same thing here. We're just trying to keep that in the soil. We tend to see, at least at Nashua, very minimal dissolved phosphorus leaching numbers. From an agronomic standpoint, you can basically ignore it. There is some potential for water quality concern there still, but from an agronomic standpoint, it's not a significant loss, but we do lose some phosphorus in runoff and erosion. So late spring snowmelt runoff in particular is one we want to be cautious of for losing phosphorus into our waterways. So again, injecting that manure, getting it below the surface, getting it covered up immediately. Again, prioritize those low testing soils, and just anything you can do to reduce soil disturbance can help reduce erosion and surface runoff. I encourage people, if they don't have them, the next time you trade up your equipment, maybe consider going to a low disturbance manure injector, which can help with that. Here's just a picture of what that looks like at the Nashua farm. So we're calling it a no-till system. It's not no-till because we are injecting manure into it, but there's a pretty minimal amount of soil disturbance there, after that manure injector's gone through. And there's a number of different companies now that are making low disturbance injectors. So I'm going to shift gears now and jump into the research that we've done, research farm. So if you're not familiar with that, that's in kind of northeast, north central Iowa, just outside of Nashua. And at that site, there are 36 1-acre drainage water quality monitoring plots. They've been in place for, since the late 70s now. So very long running experiments here. I'm going to be talking about an experiment that we did from 2016 to 2020 on these plots. So they're outfitted with drainage water monitoring. So we know how much water is coming out of these plots. And then that water sampled weekly for nitrate and dissolved phosphorus. So the cover crop plots that I'm going to be talking about, this is pretty standard management. So our cover crop treatment in this last study was an early fall swine manure. That's being applied at 150 pounds of nitrogen per acre. So when I say early fall, what we mean there is it's applied basically as soon as possible after harvest. The soils are still above 50 degrees Fahrenheit. So that's what we consider the cutoff between early fall and late fall. So our late fall applications at soils below 50 degrees. Cereal rye drilled after manure application after harvest at about 80 pounds per acre, and then terminated with glyphosate in the spring, 10 days to 2 weeks prior to corn planting, and give or take a couple days on the soybeans. So pretty standard management on that cereal rye cover crop. So I did want to show kind of just some of the weather variability that we had during this study. So what this chart's showing is precipitation or drainage. This is in centimeters. But the red line there, that's observed precipitation. You can see in 2016 and 2018, we had extremely wet, almost unprecedented amounts of moisture at the research farm there. Whereas 17, 19, and 20 were more what we'd consider normal years. 2020 was actually a little bit on the dry side. So this gives us a nice way to look at some of the impacts of this weather variability on the amount of nutrient losses that we see. The blue line there, that's the 30-year average from 86 to 2015. And then the green line is the amount of water that we see coming out of the drainage line. So the proportion of that precipitation that's ending up as drainage. And you can see that for the most part tracks precipitation, although there are some periods. If you look at late 2019 here, for example, where we have precipitation, but we don't see any drainage. And, I'd have to dig into all the weather data, but I suspect what you're seeing there is you got to keep in mind that precip, that's just a monthly average. So if that rainfall comes in smaller amounts spread over time, you may still get a fair amount of rainfall, but not see any water coming out the drain line. Just another table here showing those numbers. So I've shown precipitation and drainage depth. And so 2016, 2018, just almost unprecedented amounts of water coming out the drainage line, 14 to 16 inches of total precipitation ended up in the drainage water. And then comparing that to the historical averages there. So it's about 30 inches per year, average precip at Nashua. And the numbers were up in the 50 range in those 2 wet years. And same with drainage. I went back to a previous study, 8 years that we did there. It averaged 5.5 inches, and we're almost double that in this 2016 to 2020 study. So just quickly here, I'm not going to go through all the details, but I want to show you the water quality results. So this is showing the cumulative nitrogen loss in pounds per acre over that 5-year period. So the notation here, SU 150, that's a spring UAN side dress treatment. EFM is early fall manure. LFM is late fall manure. 150-pound nitrogen rate. The NT stands for no-till. And then the plus R here, the red line, that's our cereal rye treatment. So just comparing early fall manure with and without that cover crop, we lost almost 220 pounds of nitrogen out the drainage line over that 5-year period with early fall manure, no cover crop. Putting the cover crop in the system reduced that by about 35%. So pretty substantial gain there. Again, we're not just talking nitrate concentrations here. This is actual pounds of nitrogen leaving the drainage line. Same thing here, just showing the soybean phase. Now there's no manure applied to soybeans, so the numbers tend to be a little bit lower here. But again, we did see about a 30% reduction just by having that cover crop in the system in soybeans as well, even though there's no nitrogen being applied there. And one thing you might notice here is the late fall manure treatment here, the green line, is actually higher than the early, and that's mainly an issue with flow variability in our plots. Some of those late fall plots have been in no-till for almost 40 years now, and we do tend to see a lot of infiltration and a little bit higher drainage flow in those plots. So moving on to the cover crop and how that performed. So in 3 out of the 5 years, there was some streaking that showed up. And so anybody who's injected manure and planted a cover crop has maybe seen this. It's a little hard to make out in the picture, but you can see directly over the manure injection band, we do tend to see, significantly greater biomass growth there. And so what they did those first 3 years was actually sample those areas separately. And that's what you're seeing in this chart here. So the red bar, this is the pounds of nitrogen in that above ground biomass. We're not measuring roots. This is just above ground. Red bar is over the injection band. Green bar is between the manure injection bands. And then the blue bar, that's our soybean plots where there was no manure applied. So you can see pretty substantial amounts of nutrient uptake with that cover crop. 2019, that effect did not show up. That crop went in much later. There was no growth in the fall. That was pretty much all spring growth, but still about 60 pounds of uptake. And then 2020, crop didn't perform as well. It was a drier year. But if we look at the 5-year average there on that, so prior to corn with the manure applied, the 5-year average, that cover crop took about 80 pounds of nitrogen, 79 pounds. And then even in the soybean phase, it took up 53. Whereas if you look at our previous study with spring UAN from 08 to 15, those numbers were only 21 and 13. So if you think about the nitrogen dynamics there, with the spring UAN side dress, it's going on early spring. You put the cover crop in the fall, it's basically just taking up residual soil nitrate. Whereas with manure, that cover crop is going in right behind that manure application. So more opportunity there to take up nitrogen. And also, I think just more nitrate moving through the system and those wetter conditions may have contributed to that as well. Because you see, even in soybeans with no manure applied, it's significantly more nitrogen uptake with that cover crop. Just looking at the economics of that quickly, people don't often think about this, but that cover crop is taking up nitrogen and preventing it from being lost. So I just looked over that 5-year period. On average, how much nitrogen did that cover crop prevent from being lost out the drainage line? And then I put a value on it based on, this is 2019 data showing fertilizer prices at that point, and it was between $3 and $6 an acre. But if we look at current prices, and this number may be a little bit outdated now, but it sounds like this winter, with what's going on in Eastern Europe, we can expect to continue to see very high nitrogen prices and possibly some shortages. And so it's just something to think about here. We're preventing between 7 and 14 pounds of nitrogen from going out the drainage line. Now, granted, that nitrogen is not necessarily going to be available for the next crop. That depends on a lot of factors, but we are keeping it in the system as organic nitrogen. And I think we should be giving that a value. So at current prices, we're looking at $6 to $13 an acre. We often hear concerns about planting a cover crop, that seed has gotten more expensive. But at those prices, that's almost enough to cover your cover crop seed input. And so it's something we should be putting a value on. Moving on to yields here. So I'm not going to go through all of this data right now. I'm basically just going to focus on the cover crop, what effect that had on the yield. So basically here we're comparing the early fall manure with and without cover crop. So this is comparing the red bars and the blue bars. So you can see in 2016, we did take a big yield hit, 26 bushels per acre with that cover crop. So that was a transition year from our old spring UAN, and there was probably some issues there. It may have ran short of nitrogen that first year. Sometimes in transition years, we just throw out that data, but I like to show it just to disclose that this can and does happen out in the field sometimes if there are some issues with incorporating that cover crop into the rotation. But if you look at the next 3 years there, 17 through 19, that cereal rye cover crop treatment actually out yielded where we did not have the cover crop. And that makes sense to me. If you think about the amount of nitrogen that we're losing out of the system without that cover crop, you would expect over time to see some benefit to having that cover crop there. Now, 2020 was a very dry year. So statistically, there was no difference. It was basically a wash. And this is what we tend to see with the cereal rye in normal to wetter than normal years. We really see a benefit of that cover crop in dry years. There's very little drainage flow, not a lot of available nitrate moving through the soil profile. We don't tend to see as much of a benefit with that cover crop. So now moving on to the manure timing study. So now we're basically comparing the blue and the green bars here. So this is early to late fall comparison, no cover crop, just looking at the effect of the timing of that manure application. And you can see pretty drastic yield differences here. So in the 4 years that we have data moving from early to late fall, it was about a 38 bushel per acre average yield advantage. Now 2019 was kind of a messed up year at the research farm there. So it was really late, really cold. If you remember, the crop came out late. So what should have been the early fall manure treatment ended up being a late fall treatment. None of the late fall manure got applied in 2019. So those all became spring manure treatments. But even with our late fall to spring comparison, we saw 18 bushel advantage moving to spring from late fall. One of the interesting things that came out of that, sort of inadvertently applying that manure in the spring, if you notice here, look at the gray bars. That's our spring UAN. Historically, that's pretty much always out yielded all of our manure treatments that are put on in the fall. So 2019, however, if you look at spring manure compared to spring UAN, no yield difference. And we've got some more recent data. We're actually seeing a little bit of a yield advantage of spring manure versus spring UAN on it as a side dress. So it's not so much that UAN is a superior nitrogen source. It's really probably just the timing effect that we're seeing there. Looking at our continuous corn plots, again, we have that same timing comparison. but now we're looking at late fall to spring application. And again, across the 4 years that we have data, about a 28 bushel per acre advantage with spring manure versus late fall. Again, 2020 was dry. We didn't see any difference there. And 2019, we don't have any data because all of that manure went on in the spring. And this is actually kind of good to see here. This tells us that our plots are very consistent. There's essentially no yield difference between any of those when the manure was all applied at the same time. So just thinking about the economics of this timing issue a little bit. So I just use a kind of a longer term average corn price of 425. It's much higher than that right now, but I looked at our Nashua data. There was a similar study done down by Ames and also Wazeeka, Minnesota, looking at this early fall to late fall and late fall to spring manure timing. And so I just kind of summarized all of those, combined the data. So if you look at the average going from early to late fall, 13 site years of data there, about a 20 bushel per acre advantage with the late fall manure. Late fall to spring, we only have 5 site years of data there, and that's all from Nashua, but a 26 bushel advantage in that case. So pretty significant economic difference there when you start looking at what our corn prices are. We also had an instinct inhibitor treatment in those continuous corn plots. And so 2016, we did see a yield advantage, but that again, that was a transition year. 2015, those plots were in soybeans. So we're basically just throwing that out. But 2017, 2018, 2020, where we had data on average 12 bushel per acre yield advantage with that instinct applied with late fall manure. 2019, again, that manure all went on in the spring, so we don't have any data there, but we are seeing a yield advantage. But on the water quality side, I didn't show the data, but we basically see no effect from that instinct treatment when it comes to drainage water quality. So seeing a yield advantage, no difference on the water quality side. Same thing here. I just kind of summarized a bunch of that data on nitrification inhibitors from different studies. I use the same corn price. Again, we've got our Nashua data here. There was a study in Boone, Iowa, and also Wazeeka, Minnesota, looking at both early and late fall instinct applications at different rates. And if you just kind of look down the yield column there, anything with an asterisk behind it was not statistically significant. But kind of the interesting thing that came out of that is when I grouped those by timing. So when we look at early fall manure with instinct, 14 site years of data, almost a 13 bushel per acre yield advantage in that case. Whereas if we look at the late fall data, 17 site years of data, it's under 4. So that's getting down to that range. You got to consider this does not include the cost of the instinct. You still have to pay for it with that yield increase. And my number there for instinct costs, I'm sure is outdated. I don't know where it's at right now, but that's something you have to factor in, especially at that higher instinct rate. What is that costing you versus what kind of yield advantage are you going to get from that? So overall average about a little under 8 bushels per acre with the instinct. So the answer, should you use it or not, is always, it depends. So where we tend to see the biggest advantage with the instinct is that period kind of 2 to 3 weeks before the soils get below 50 degrees. Once they're below 50, that nitrification process is already starting to slow down anyway, so you don't tend to see as much of a benefit from that inhibitor. So just to summarize things here, the cereal rye cover crop, we did see a significantly reduced nitrogen leasing loss, both concentrations and total pounds per acre going out the drainage line in that early fall system where we had that cover crop. It did take up a substantial amount of nutrients in that cover crop. Again, 50 to 80 pounds of nitrogen in that above ground biomass over the kind of a 5-year average. And 3 of those 5 years, we did see significant growth differences directly over that manure injection ban. Very significant effect on yield with our manure application timing. Generally, the spring manure yielded the best, followed by the late fall manure, and then the early fall manure with the poorest yield. And then on the nitrification inhibitor, again, we are seeing a yield advantage there, but we did not see any effect on water quality with that nitrification inhibitor. So just want to acknowledge some people here as we're wrapping up, the different funders that have participated in this over the years, and all kinds of folks, too many to mention here that have been a part of this project. Give a special shout out to Ken Pekanofsky and all the staff at the research farm there that do a lot of the heavy lifting and the data collection for this project. So with that, I will wrap it up. Happy to take questions. And if you do want CEU credits, you can see the information there. I will let Liz go over that.
Yeah, so if you joined today and you want credits, go ahead and get those sent over to Alena, and that's ALENAW@iastate.edu by 5 p.m. today. And so, yes, questions have been coming in. Curious, you noted there that spring manure is beneficial to yield, but how do you handle spring compaction with the spring manure applications? How is that applied in this particular study?
Yeah, that's a great question. So it was injected in this particular study, but that's one of the things that really makes people shy away from applying manure in the spring. One is just the timing. Generally once conditions are fit, people want to go and they want to start planting. And the other big concern is compaction. And this is something I think we need more research on, is looking at the effect of that spring manure. And we do have a trial going on right now with spring manure. We're in the early stages of that, and I believe compaction is one of the things they're going to look at there. But it's certainly a concern. So that's just a trade-off you have to think about. The data that we have suggests that, even in spite of that compaction, we're still seeing the yield benefit. And so I don't have a great answer on that. It's certainly a concern. You want to stay out of that field when it's kind of right at field capacity or that soil's saturated. That's where we see the most damage from compaction.
Someone's curious, have you heard of anyone adding humics or carbon source to the manure before application?
That is a really good question. I have not heard of anyone adding it to manure. There's a lot of people adding it to, other nitrogen products, liquid UAN in particular, or spray mixes, chemicals, herbicides. Those are all good candidates for using humics. You certainly could add it to your manure. That wouldn't hurt anything. Swine manure does tend to be, fairly low in solids content, or what we call organic matter. So that would if you were going to do it, maybe be a better fit. Your dairy manures and beef manures tend to have, a lot of carbon in them already. So again, it certainly wouldn't hurt anything. I haven't heard of anybody adding it to manure. But if I had to pick a place to go with those humic substances, I would put it to more of the purchase fertilizers first. And then if you still want to add more, you could add it to your manure.
So curious here, what effect does the 179 pounds of phosphorus with manure application have on the water quality side of things?
Great question. So there's a lot of components that go into water quality. What we typically do for manure application here in the state of Iowa is use the phosphorus index. And so the soil test phosphorus level is one component that goes into that. But honestly, the amount of phosphorus that's in the soil on the soil test is probably less important than how much erosion you have. So we also do a Russell 2 erosion calculation that's part of that. And then the amount you're applying goes into it. What do you have for buffer widths? So there's several different components, but the erosion component is the most important. So if you can keep that soil in place, you can have fairly high testing phosphorus soils and still not really see that impact, at least from surface runoff for phosphorus. Now, dissolved phosphorus going through the drainage line, that's a separate issue. And that is a problem, particularly up around the Great Lakes areas. They tend to have like shrink swell clay soils that can crack a lot. They tend to see more dissolved phosphorus loss. We have some data from Nashua from 08 to 2015. We've got a paper on it if you want to dig into the details, but dissolved phosphorus losses at Nashua were, I would say, minuscule. You're talking grams per acre. So it's a very small amount. However, there are specific events where maybe you get a heavy rainfall after a dry period. You can see spikes in that dissolved phosphorus content in the drainage line that could potentially cause a water quality problem. So it's not that it's a non-issue. It's just I would be more concerned about the surface runoff component of that.
So in this case, your cover crop was not harvested, correct?
That's correct. It was left in the field and just terminated with glyphosate.
So they're curious, is it possible that your nitrate reduction efficiency could go down over time because the cover crop was not removed? Or is more research needed?
I mean, just off the top of my head, I don't think that would be an issue. The advantage of leaving that cover crop there is you're going to build up your organic matter levels potentially over time. And that's one of the big advantages of using cover crops. We're keeping a living root in the soil. We're recycling more carbon through the system and getting more of that into the soil. And if you can increase your organic matter levels, organic matter for the most part has a negative charge, but it does have some positively charged sites as well that can help hold on to some of these nutrients. It's basically a sponge is a way to think about it for nutrients and water. So I don't think removing or leaving that cover crop there would have an effect on, becoming less effective over time. I would expect the opposite.
So speaking of organic matter, someone was curious if you looked at organic matter in your plots with and without the cover crops to see if there was any changes during your study.
Yeah, another great question. So we do have a lot of soil carbon data, both 0 to 6 inch and deep cores down to 1.2 meters at this site. It wasn't part of this particular study, but we are monitoring that. In a nutshell, what we're seeing is from 0 to 6 inches, there's a lot of annual variability. So we don't tend to pick up any nitrate or organic matter increases over time in these plots. They seem to be fairly steady. That said, they are pretty high already. So this is a very fertile soil. So they're already in the 3 to 4% range. And the higher your organic matter is, the more difficult it becomes to increase that over time. On the deep cores, though, we're seeing some really interesting things there. We're not able to detect a change at the surface, but we are seeing increases in soil carbon at depth, so below 30 centimeters. But the crazy thing is that's happening in almost all of these plots. So it didn't really matter if it was cover crop or not. We are seeing that increase happening deep in the soil profile. And that's something we need to continue to track and try to figure out what's driving that or why we're seeing that, because there's other research sites around the country that are seeing the opposite. And so I'd say, yes, we're tracking it. The cover crop specifically, we haven't really picked up a big effect of that yet at the surface, but we are seeing effects deeper in the profile.
And you had noted in the transition year of yield that there may have been some deficiency in nitrogen available. Could that have been resolved with maybe some late spring nitrate sampling or other management choices in the season?
Absolutely. And that's one of the downsides of these research trials. So we set them up and we're going to do things a certain way. And so you basically have to keep doing it the same way throughout the duration of the study. Otherwise you mess up all your data. But, from a farmer's perspective, if you were doing this, you'd want to be monitoring that, potentially coming back and doing some side dress nitrogen if you're seeing some deficiencies or shortages there. The way we set up this trial, we didn't have the ability to do that. That's something we have talked about maybe we should do for studies in the future, because that is the way a lot of farmers are managing, on large scale acreages. So typically, ideally with manure, you wouldn't try to put on your full rate in the fall. So you would do a lesser rate and then come back in the spring with a side dress, especially if you have enough acres to spread that manure over. So that's certainly something that could and should be done for people that are, managing fields out there. I would encourage you to do late spring nitrate or just monitor things. There's leaf tissue tests or sap tests. There's different ways you can, test and determine if you need more nitrogen.
All right. So if folks have more questions, feel free to get those in. But Brian, if you want to go ahead and advance to the next slide. Because next week, you can join us again at noon. We're going to be hearing from Tricia Moore at Kansas State University, talking about some urban and rural watershed management choices. So thank you for folks joining in today. Again, if you have a few more questions, you've got a little bit of time to get those in. Otherwise, you can always search for Brian through Iowa State University Extension Outreach and get him your questions as well. It's been a privilege to host you here, Brian. It's hopefully to see you around the state here shortly. And have a great afternoon, everyone. Thank you again.
Yeah, thanks for having me.